Welcome to this explainer. Today, we are diving into an absolute game changer in the artificial intelligence space, Alibaba's brand new open source model, Qwen 3.8 Max. We're going to unpack what this massive release actually reveals about the shifting global AI landscape and exactly why it's turning so many heads across the tech industry right now.
You know, what's really fascinating right off the bat is how the developers introduced this model. They painted this highly optimistic, incredibly relatable vision of the future. Picture this, you're out fishing, playing a match of tennis, or maybe going bouldering, all while the AI is back at the desk doing the actual heavy lifting, putting together those tedious spreadsheets or crunching scientific research. It is a really refreshing contrast to the doom and gloom sky is falling narratives we so often hear from the big closed-source labs.
So here is our roadmap for today. First, we'll meet Qwen 3.8 Max. Then we'll look at its AI capabilities, followed by research reproduction. After that, we'll break down pricing and model size, dig into the benefits and geopolitical risks, and finally, wrap up with the big debate, open versus closed source.
All right, let's jump right in. Section 1. Meet Qwen 3.8 Max.
Qwen 3.8 Max comes in at a massive 2.4 trillion parameters. Yeah, trillion with a T. This puts it neck and neck with other recent Chinese open-source heavyweights like Moonshot's Kimi K3, which sits right around that 3 trillion mark. Establishing this sheer scale early on is absolutely vital. It proves to the world that this isn't just an experiment, it's a true frontier-grade model. It has open weights, and incredibly, it's completely free for anyone to download and use.
Moving right along to Section 2, AI capabilities. Now, when we stack Qwen up against the very best closed-source models out of the US, a really fascinating picture starts to emerge. Sure, Qwen Suite Pro's score of 67.7 does trail Fable's leading score of 80. But look at this. It hits a wildly impressive 86.6 on the crucial terminal bench coding test. That actually beats Fable and sits just barely under GPT 5.6 Sol. And when it comes to multimodal reasoning, real-world spatial understanding, and visual perception tasks, it absolutely dominates the pack. No question. Next up, Section 3, Research Reproduction. Okay, this part is honestly mind-blowing because it's basically the prerequisite for automated AI research. Starting with absolutely nothing but a research paper and a cluster of GPUs, no starter code, no hand-holding, Qwen 3.8 Max didn't just write the code to reproduce the paper's results, it impressively turned that reproduction into self-evolution. It literally invented and tested 18 of its own improvement ideas across 4 distinct rounds. This is a massive hint at true recursive self-improvement, where an AI is out there discovering new algorithmic unlocks entirely on its own. And that brilliantly illustrates another huge capability. Qwen 3.8 Max can handle the autonomous execution of the entire silicon design flow. It uses a closed-loop, feedback-driven optimization process just to design chips. Why does this matter? Well, one of the main areas where China currently lags behind is in chip design and manufacturing. Having an AI model capable of autonomous execution in silicon design could, quite frankly, help them overcome that specific critical bottleneck. Let's look at the economics. Section 4, Pricing and Model Size. Looking at the raw token pricing, Qwen is just vastly less expensive than its US counterparts. We're talking just $2 per million input tokens and $6 for output. Now compare that to GPT 5.6 Sol at $5 in and $30 out, or Fable at a staggering $10 in and $50 out. It's a tiny fraction of the price. But hold on a second, because that doesn't tell the whole story. You see, token efficiency varies wildly from model to model. We really have to look at the cost per task completed, which is the actual number of tokens required to finish a specific job. To give you some context, while 3.8 Max hasn't been completely charted here yet, the previous version, Qwen 3.7 Max, cost about $1.28 per task. That is actually slightly more than GPT 5.6 Sol's incredibly efficient $1.23 per task. So a lower token price doesn't automatically mean a cheaper task, especially if the model needs to churn through more tokens to get the same job done. This economic reality is tied directly to model size and raw compute power. We are essentially watching a model size divide unfold. Chinese labs are currently maxing out in the mid to 2 trillion parameter range with models like Qwen and Kimi. On the flip side, US labs, who are utilizing vast NVIDIA GPU compute advantages, are pushing 7+ trillion parameters with models like Fable and the upcoming Astra. I mean, to run models of that size, you essentially need the power grid of a small city. At the end of the day, it really all comes down to how much raw compute you have access to. Which brings us to Section 5, Benefits and Geopolitical Risks. In the short term, these Chinese open-source models are fantastic for enterprises. They give businesses highly capable, cost-effective alternatives to paying sky-high premiums for closed-source models. Companies get complete model ownership, the freedom to fine-tune without worrying about platform dependency, and, crucially, they can download and run inference safely right here on U.S. soil without ever sending a single byte of data to China. It gives the business world immense optionality and helps prevent a dangerous monopoly of AI power. However, there is a long-term geopolitical risk here, and it's being called the hardware trap. Think about it. As U.S. companies naturally rely more and more on these cheaper Chinese open-source models, because, hey, 95% of the capability at a fraction of the price is hard to pass up, there's a catch. These models may eventually undergo extreme co-design. That means they will be specifically optimized to run best on Chinese chips to achieve maximum efficiency. So by becoming dependent on their open-source software now, we could eventually create a severe dependency on adversarial hardware down the line.
And that leads us perfectly into our final segment, Section 6, Open versus Closed Source. This is the ultimate philosophical and economic battle right now. Will incredible open-source models like Qwen completely commoditize the AI layer, effectively driving the base value with intelligence down to zero? Or will the closed-source labs with their massive compute advantages pull so far ahead that it doesn't matter? Think about how OpenAI recently used recursive self-improvement to make their Soul model so incredibly efficient that they could just casually drop prices by 80%. If closed labs are already unlocking true recursive self-improvement, the open-source price pressure might not even make a dent. So I want to leave you with this pivotal question to chew on as you watch these trillion-parameter titans battle it out for the future of global intelligence. Does open source truly matter in the long run, or is recursive self-improvement the only goal that actually counts? Thank you so much for exploring this topic with me today. Keep analyzing the trends, and I hope this explainer gave you a much clearer picture of the incredible road ahead.
If you enjoyed this video, please like, comment, and subscribe for more AI and technology content. Thanks for watching.